Okay, so we are on part 7D now. For 7D, you don't require any CRO or neither you require any signal generator, just a supply, fortunately, but before, and that to a single power supply. So we will go to the pin diagram of next IC is LM324, and we will do some modification. So you don't want anything from this, neither your IC, nothing. You can just take them off. It's good to destroy the circuit than to create. So we require 3 resistors to keep them. Okay, so we don't require any capacitor now. And we require this new IC called LM324 single supply op-amp. But to be very careful while inserting the new IC, none of its pins should bend. Okay, they are okay. So again this becomes precisely your pin number 1, and we have to connect a VCC. So we don't require this now, minus 20, because it's a single power supply, and we can connect it to plus 6 volt for any input that we need to give. Okay, so circuit we need to construct now is part 7D. This is totally separate from first circuit. So you have your first op-amp whose positive will be fed by the input capacitive, and negative is having a resistor between its output and input, and that value of a resistor is 10k. So I would select one 10k. Okay, before doing any connection, let me connect VCC and ground. So VCC at pin number 5, pin number 4 of the IC. So pin number 1, 2, 3, 4. We can insert it at pin number 4, and ground is at pin number 11. So let's select one more wire for that grounding. So it's a 7 pin IC on this side, 8, 9, 10 and 11. So this becomes my ground. Okay, so single supply, and that could be of 10 volts or even lesser also, depending upon what gain you expect. And next thing is you have to connect the circuit. So 110k, you can see how the op-amps are structured inside. Minus at pin number 2 and output at pin number 3. So 110k between those two. So pin number 1 is your output, and pin number 2 is the inverting terminal. So a resistor of 10k between pin number 1 and 2. Next is one more op-amp with negative terminal of feedback of 10k and a positive terminal going for an input. So we will check again. We have another op-amp. At pin number 14 is the output, 13 is negative and 12 is the positive. So another 10k, such symmetry. So it will go between pin number 14 and pin number 13 of the IC. Now There is a variable resistor you need to put. Right now I will put 4K7, that is 4.7K between those two 10K on the negative terminals. So it's exactly connected between two negative terminals. So this is a 4K7 IC connecting between pin number 2 and 13. Okay, so pin number 2 and 13 is I1, 10 and 4K7. That resistor you keep on varying. Next is this goes to a network of 2.2K to a third op amp, another 2.2K. Any value are fine. Connection pattern remains same. So again from minus to plus of the op amp. So let's select that third wala op amp, that is pin number 7 and 6 with 2.2K. So pin number 7 to pin number 6 is 2.2K, and then from that negative terminal, so that negative terminal goes to one of the outputs. So output you can select pin number 1, whichever you want. That is convenient. Make sure you are not shorting anything. You see how clean connections are these. Okay, we are not shorting anything with any terminal also. And the second input goes to another 2.2K, which goes to ground as well as positive terminal. So we require two more 2.2K. So this goes to the positive. So we connect it to output, and from that it should go to the positive. So I will put one wire because it's getting messy. I know it's kind of boring listening to this video, but it's very fast if you follow it. So from 2.2K goes to positive terminal, and the same point goes to ground. So I require another 2.2K, which goes from the same point to the grounding. So this completes my circuit of instrumentation amplifier. The output terminal is at pin number 7 for this network, whichever is your last op amp. You connect one wire for DMM and one wire for a grounding. So you have two wires where you will connect your DMM, these two wires, and two wires for the input. So let's select these two wires. So input it as now, as per the circuit we have made, is at pin number 3 and pin number 12. So third terminal, and it's exactly symmetric opposite terminal. Now this input can be anything AC, DC, depending upon what facilities you have. If you have signal generator, apply an AC. If you have a same DC supply, you can connect it to the plus 6 volt, and the other terminal, that is other input, should go to the ground. So this goes to the ground. So this makes a single supply instrumentation amplifier. Make sure you keep this plus 6 volt exactly at 0 and turn on the supply. Vary this plus 6 volt from a small range, very small values, and check what is the gain of this circuit onto your DMM in DC voltage mode. This is how you should perform this experiment.